Assalamu alaikum. In this session, two short video, we are going to talk about hypergeometric distributions, as this topic is not included in the lecture 10 version. So we need to make this video. Also, we need to make a student distinguish between hypergeometric distribution and binomial distribution, as still some students get confused between binomial distribution and hypergeometric distributions. Inshallah, by ending of this video, student will be able to know the difference between these two distributions. Both hypergeometric and binomial distribution are discrete distribution. Both are discrete. Hypergeometric distribution and binomial distribution are both describe the number of success in a fixed number of trails. However, binomial distribution, as we know, trails are independent, but hypergeometric distribution trails are dependent. This is the only difference between hypergeometric distribution and binomial distributions. All other remaining same. The only difference is binomial distribution trails are independent, while hypergeometric distribution trails are dependent, because we use a method of without replacement when we draw a sample from populations. So we use method of without replacement. This makes hypergeometric trails dependent. For example, the second trail depends on the first, and the third depends on the second and the first. So let's see the condition of hypergeometric. As we know, in binomial distribution, we have 4 conditions. Also here we have 4 conditions. So it is same, only the difference is the last conditions. Total number of item population should be fixed. Sample size, number of trails, is portion of the population. This means the sample size should not be exceed the number of populations. Should be less than or equal the number of population. Number of success in a sample is fixed. So number of success in the sample is fixed. Probability of success change after each trail, as we mentioned before. This makes trails dependent because we draw without replacement. So this is 4 conditions of hypergeometric distribution. Let's explain hypergeometric distributions. For example, if we have a population of size n capital, out of this n we have k number of success. So we have k success out of n. So this n we can divide it to 2 parts. K is the success, and n minus k is not success. So k success, n minus k not success out of n. And we draw a random sample without replacement. This is too much important. Without replacement. Let x be the number of success in this sample. Number of success in this sample. So this n also can be divided to 2 parts. X, number of success, and n minus k, number of not success. So not success in our population. Let's see, we divide our population to two parts. First part is K, second part is N minus K. Also our sample, we divide it to two parts. X is number of success and N minus X number of not success. So success definitely come from success, and not success also come from not success. So in this case, if we draw without replacement, then this follow a hypergeometric distribution, and we write it N K combination X. X success out of K success multiply by N minus K not success combination N minus X not success over the total number of selection. We select N sample out of N capital population. So just like N, this is the total number of selection and come from N. So we choose N small out of N capital, and we divide this N to two parts. This is our population. We divide it to K success and N minus K not success. This success and this not success. Our sample also we divided to two parts, X success and N minus K not success. And the formula written like probability of X equal N K combination X, N minus K combination N minus X over N capital combination N small, and X take values 0, 1, 2, 3 up to N, same like binomial distribution, also take same values. We write X distributed hypergeometric with this N sample size, K number of success in the population, this population size, N capital population size. K is number of success in the population and N is our sample. If I know these two values, then I can find the probability of X, because X is the variable, take this value. Clear? Let's take example. We have example, a box consists of 24 transistors, 4 of which are defective. So this is K, and this is our population size. If 4 are solved, so this is our sample. Find the following probabilities. Let's see first, is it binomial or a hypergeometric distribution? Let's check our conditions. N known, yes. K known, yes. N known, yes. Drawing with or without replacement. Solve means without replacement. Without replacement. So it is binomial, it is a hypergeometric distribution with N, K, and N. So we write X distributed hypergeometric with 24 and 4 and 4. N, N, and N. We write the function as probability of X equal, let's write the general form. This K combination X, N minus K combination N minus X over N capital, combination N small. X take which value? X take 0, 1, 2, up to 4. 3 and 4, let it write 3 and 4. K equal 4, N minus K equals 20. So you can write this 4 Cx N minus K is 20. 24 minus 4 is 20. Combination M minus X. N is 4. 4 minus X. X is our variables. Over N is 24. Combination 4. So we use this to find each value of these questions. Just we can value X. Let's see, let's solve the first one. First one means exactly 2 means X equals 2. So just we come, instead of X we write 2. So for P of X equal to, question 1 is 4C2 multiplied by 20 C2 over 24 C4. Y calculators. 2 is none of them are defective. None of them means X equals 0. 0 defective. So instead of X we write 2 P of X equals 0. Instead of X we write 0. So 4C0. 4C0 is 1 multiplied by 20 C4. 4 minus 0 is 4 over 24 C4. This equals 20 C4 over 24 C4. 3, let's see, 3, all of them means X equals 4, because actually we have 4, we solve 4. So P of X equal 4 is, instead of X we write 4, it's 4C4 multiplied by 20C0. 20C0 is 1. 4C4, 4C4 also 1 over 24C4. It is 1 over 24C4. 4C4 is 1, 20C0 is 1. Okay, let's see the last one. Last one, at least one of them. At least means P of X greater than or equal 1. Is equal P of 1 plus P of 2 plus P of 3 plus P of 4. So actually, because X take value 0, 1, 2, 3 up to 4. So it's all value except 0, so we use complements, means 1 minus P of 0. We already have P of 0, so this is 1 minus P of 0. P of 0 is this one. Is 1 minus 20 combination 4 over 24C4. We use calculator to find the exact value of these probabilities. Here we have the exact value of these probabilities. 2 defective, so 2 out of 4, because we have 4 defective, so 2 out of 4. and we have 20 non-defective. If we have 4 defective and our total of sample is 4, so we have 2 non-defective. So it is 4C2 multiplied by 20C2 over 24C4. This is a value. None means we put x equals 0. So x equals 0, we have 4C0, 4C0 equal 1. That's why it's not written here. Multiplied by 20C4 over 24C4. All means x equal 4. So we write 4C4 multiply by 20C0. 20C0 also equal 1. 4C4 equal 1. So we have 1 over 24C4. At least one means 1 minus P of 0. P of 0 is 1 minus 20C4 over 24C4. Here we have 20C4, we have 4C0. 4C0. It's like none 4C0. So this is the hypergeometric distribution. Hopefully now it is clear. Now let's convert this question to binomial distribution. As we mentioned, the only difference between binomial distribution and hypergeometric distribution is hypergeometric distribution trails is with trail is dependent, while in binomial distribution trails are independent, or drawing with replacements in binomial distribution and drawing without replacement in hypergeometric distribution. So now let's see how this question can be considered as a binomial distribution, in which case just we need to make these trails or this selecting independence. How? Just we know when we use drawing with replacements, then trails will be independent. So just here, if 4 are solved at random instead of solved, we mentioned solved means without replacement. So just we need to write this if 4 are selected with replacement. Selected with replacement at random. So just instead of are solved, let's write are selected or drawn with replacement. So in this case, this is a binomial distribution. Binomial distribution has 4 conditions. First condition, we have 2 outcomes, yes, defective or non-defective. B should be known and remaining same. So how to find B? B is number of defective is 4 over total number is 24. So it is 1 over 6. This is P. This is the first. This is the second condition. Third condition, N should be known and fixed. This is N is known and fixed. Trail should be independent. This make trail independent. So now this is a binomial distribution and can be written as X distributed binomial with two parameter, which is n and b, n equal 4, b equal 1/6. P of x of binomial distribution is n cx p power x q power n minus x, and x takes same values like geometric distribution, like hypergeometric distribution 3 and 4. So just to find these probabilities, instead of x, we use, for example, 2 exactly. So we use x equal 2. We have n equal 4. We have b equal 1/6. Q is 5/6. So let's substitute these values. B of x will be equal, n is 4, combination x. B is 1/6, combination x. Q is 5/6, combination 4 minus x. So solving the first question means x equal 2. Just we find p of x equal to is, instead of x, we put 2, so 4cx 1/6 power 4c2 1/x power 2, 5/x power 4 minus 2 is 2. So 4c2 is 6. 1/6 is 1/36. Multiply by 25/36. This is 25/2 Of course, it's different from when using hypergeometric distribution. For the second one, none of them are defective. As we mentioned, this x equal 0. So 2p of x equal 0. We put x equal 0. 1/6 power 0. 5/6 power 4. 4c0 is 1. 1/6 is 1. 5/6 power 4 is 6 to 5 over 1 to 9, 6. Of course, also different from when using hypergeometric distribution. Number 3 is all means x equal n. So p of x equal 4, we put x is 4, 4c4, 1/6 power x, x is 4, q is 4 minus 4 is 0. This is 0, this is 0, so we have 1/x power 4, which is 1/1 to 9 6. The last one is at least one means p of x greater than or equal 4 or equal 1, which is p of 1 plus p of 2 plus p of 3 plus p of 4. This means 1 minus p of x equal 0. Equal 1 minus b of x equals 0 already got it. So we just b of x equals 0 is 2/6 and then 25 over 1,296 equals 761 over 1296. Of course, also this is different from the value when we use hypergeometric distribution. So now this is the difference between hypergeometric distribution and binomial distribution. As we see, the only difference is trails independent, we use binomial. Trail dependent, we use hypergeometric distributions. I think now it is clear, and you know how to distinguish between using hypergeometric and using binomial distribution. So now, inshallah, you are ready to go to test 2. Wishing you all the best, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.